Hello, so today we'll be going over question 5.5 on the homework. So for part, let's draw the diagram first because all the questions in 5.5 they're using the same diagram. So we have a cart on an incline. So here's the incline. Here we have a cart dragged by a rope, and down here is there's the bucket. This is the cart, and this angle we call it alpha for now. And let's do the free body diagram. So for the cart is, here's the cart, and here along the slope is the tension by the rope, and the perpendicular to the slope is the normal force, and straight down to the ground is its weight. And let's draw this line right here and back here. So we know the angle for this is alpha, and this force backwards we can call it drag or friction because it's moving upwards, and this force is equals to the weight times sine alpha, so it's same as this one. So weight times sine alpha, and this is weight times sine alpha. All right, so and for the bucket we have the tension straight up and its weight straight down. So this is the weight of bucket, this is the weight of cart. All right, so for part A and B, let's do part B first because it asks for the tension. So we know the weight of the bucket is 255, and both the cart and the bucket, they're moving at constant speed. So the net force of the bucket is equal to 0 because it's moving at constant speed. That way we know the tension is equal to weight of the bucket, which is 255 Newton. And that answers question B. And for question A, so let's do this. So that's B. Here's the A. It asks for the weight of the cart. So as we know, the cart is also moving at constant speed. So F net of cart is 0. So the both what we call the x-axis forces, the sum of it is F net is equal to 0. So the tension equals the weight of the cart times sine alpha, which is 255 Newton equals to the weight of the cart times sine of 36.9 degrees. So the weight of the cart equals to 255 Newton divided by sine of 36.9 degree, which gives us approximately 425 newtons. That's for part A and B. And for part C, let's see. Part C here, we with the same diagrams, we just changed the slope to 23 degrees, and we have the different cart and different bucket, and now we know the both of the cart and the bucket remain at rest, and the tension in the cable is 100 175 newtons, and there's no friction or anything. And part C is asked for the weight of the cart. So also we use, since it's at rest, so that means the tension on the rope is equal to the friction, which is weight of the cart times sine alpha. So the weight of cart then equals to the tension divided by sine alpha, so equals to the tension we know is 175 Newton and the sine of 23 degree, so it equals to approximately 448 newtons. So that's the weight of the cart. And for part D, as for the combined weight of the cart and the bucket. So we know for the bucket it's also at rest. So the tension is equals to weight of the bucket, which is 175 newtons. So the combined the weight combined then equals to the weight of the car plus the weight of the bucket equals to 448 newtons plus 175 newton is equals to 623 newtons. So that's part C and D. And for part so part E, let's see. Okay, so we still have the same diagram, and we change the cart of mass. So mass of cart equals to 185 kilograms, and the mass of the bucket equals to 63 kilograms. And still the same, there's no friction, and we don't count the cable of the mass, the mass of the cable, sorry. And still it says the cart moves downhill at a constant speed. So the weight of the cart equals to the mass of the cart times the G, and the weight of the bucket equals to mass of the bucket times G. So still the same thing, so weight of the cart equals to tension equal not the weight of the cart. So as for the diagram, so this force right here is equals to tension, so that means weight of the cart times sine alpha equals to tension, and equals to the weight of the bucket. So question E, it asks for the slope. Yes, the slope. So we have times P. MCG times sine of alpha is equals to M bucket times G. And then we can tell, so sine alpha equals to mass of the bucket times G divided by mass of the cart times G. And then alpha equals to inverse sine of mass bucket times G, mass cart times G. And we just plug in all the numbers. So inverse sine of the mass of the bucket, which is 63 kilograms, times 9.8 meters per square second, divided by 185 kilograms times 9.8 meters per square second. And then it gives alpha, the angle, is approximately 19.9 degrees. In part F, as for the tension on the cable. So the tension of the cable, since it's moving at a constant speed, so on the y-axis, so the tension on the rope on the cable is equals to the weight of the bucket, which is, so the tension equals to weight of the bucket and equals to bucket times G is equals to 63 kilograms times the G is 9.8 meters per square second equals to 617 newtons. And G. Alright, so for part G, so now we have there is a friction. Let alpha be the angle of the slope, and there is friction between the car and the track. You find the car that same weight, car and bucket each had the same weight W, and they remain at rest. So when they remain at rest, that means the F net equals to 0, and for the cart, so we have we have the tension. So since net force on the cart is equal to 0, so we have the tension on the cable plus the friction is equals to this downhill force. So W time the weight the weight times the weight of the car times sine of alpha. So the weight of car is W times sine alpha, and since the bucket has the same weight as the car, W, and the tension equals to the tension equals to the weight of the bucket. So we have the W plus friction equals to W times sine alpha, and we move the term with W on one side, so the friction equals to W sine alpha minus W. Wait, sorry, let me see. So so let's bring this down here. So let me copy. So copy this and we drag it down here so we can easily see. So the on this force is equal to 0. So oh yeah, sorry. So whenever it's at rest, so this is the friction down here. So I made a mistake. So is the friction plus the friction plus the this force right here. So the weight component, so the weight times sine alpha equals to tension, and the tension equals to W. So friction plus W sine alpha is equals to W. So the friction equals to W minus W sine of alpha, and when we simplify it, so it's F equals to W times 1 minus sine alpha right here. And for part H, yes, for is the friction force less than or greater than or equal to W. So the friction force F, since we know sine alpha is less than 0, and 1 minus sine alpha is also less than 0. And so we know the W times any number that less than 0 is smaller than W. So F equals to W times any number sine W is smaller than W. So F is smaller than W. It's less than W, yeah, the frictional force. And yes, and that's all these questions here. And thank you.